shop, the future's calling. Maths and mind colliding. Daily dose of power. AI's here. See ya.
Kubeka, let's learn the new way. Guys, welcome to the Daily Dose of Mathematics. We are continuing with question 7 from Limpopo June 2026 question paper. Itu, what are we doing today?
So today we are doing optimization, which is 7.2 says the measurement of a rectangular dam are as follows. The length L is equal to 60 minus 2x, which is this one. L.
Okay.
And then we have width is 2x, width is this one. And then we have a depth, which is x all over 2. Depth is this one.
Okay, guys, we're going to be going through this question and then we're going to do it 7.2.1, 7.2.2, 7.2.3. And then because this one, it seems as if they made our life a little bit simple because most of the time, the challenge is that we need to make every variable in terms of one variable, like each and every dimension. We have your length, your height, your depth. So you should try to make sure that you make them to be according to one variable. Most of the time, we usually use x. So today, they've already done that for us. They've already made everything in terms of x.
Yes.
So that's the most challenging optimization. Now, we're also going to take the solution, put it in our senior marker. Once we're done with 7.2.1, we're going to put it in the senior marker. We also have an optimization song that we're going to play. Now, let's start with 7.2.1.
Yes.
7.2.1. Yeah, what should we do?
7.2.1 says solution. Determine the volume of the dam in terms of x.
So the volume, guys, these formulas are not going to be provided in the information sheet. You should remember that if you are dealing with a rectangular prism, a dam, it's going to be a rectangular prism.
Yes.
So for you to be able to calculate the volume of any rectangular prism, you need the 3 dimensions that they gave you. In this case, they gave you what?
They gave you the length.
The L multiplied by?
They gave you a width.
Okay. W multiplied by?
They give you a depth.
The depth.
Yeah, the depth.
Okay, but the correct formula that we use for volume, we say V is going to be equal to L times B times H. Now, the L times B times H is exactly whatever it is that they gave you here, the dimensions that they gave us.
Yes.
Okay. So with that being said here, we're simply going to substitute. As you can see, guys, there's nothing scary here. You simply substitute. The only thing that you can say, maybe you have a challenge, is to remember what is the volume of a rectangular prism. So what is our length?
Our length is 60 minus 2x.
It's 60 minus 2x.
Yes.
Sharp. Then what is our width?
Our width is 2x.
It's 2x. Okay, sharp. What is our height or our depth?
Our depth is x all over 2.
It's x all over what? All over 2. Okay, as you can see here, we can, like every time when you're dealing with multiple brackets, it's easy for you to start with the simplest 2 brackets. Now, the 2 at the end, you have 2x, and then you have also x all over 2. You can start with these 2, forget about that one, so that you don't complicate your life now.
Yes.
So I'm going to tell them that V is equal to?
V is equal to?
The first one will leave it exactly the way it is. Again, it's 60. Open bracket, it's 60.
Minus 2x.
Minus 2x, yeah. And then if you say this 2, you say 2x multiplied by x all over 2.
2x all over 2 is same as 1 all over 2. So then we're going to say 2 multiplied by 1 all over 2. 2 multiplied by half.
Yeah, so what do you get?
Let's multiply 2.
We get x
squared
squared
by half. It's going to be x squared now.
Yeah, because actually the x is in the numerator. Can you see that?
Yeah.
So x multiplied by x, they're going to give us x squared. But the 2, the other one is in the denominator, the other one is in the numerator. So they're going to divide each other out.
So now we're going to get x squared. How did you get x squared? X multiplied by x is the same base, and then we're going to add the exponents. Exponent is 1 plus 1 is equal to x squared.
Sure. Okay, now we can then bring in our bracket. Then foiling, we're going to say x squared multiplied by 6. Then.
Yeah, you're going to have 60
x squared.
X squared.
X multiplied by minus 2x.
X multiplied by minus 2x is
minus
2x cubed.
Okay. Now, straightforward. There was nothing special here.
Yes.
They're going to give us 2 marks for this. Now, let's just check if we've used the correct notation, because what is important, guys, as you're preparing for the examination, is to make sure that you are using the right notations that they are using in the marking cell. So I'm going to take the solution, put it in the senior marker. Now, I have a song that has to do with optimization. Let's go to optimization song.
Okay, let's play our optimization song.
Welcome to the Daily Dose of Mathematics. Daily Dose. Optimization questions, don't let them trick your mind. Trick your mind. All big, it's not just volume, any formula you can find. Any formula you can find. Surface area, perimeter, or profit on the page. On the page. On the page. Read the question carefully.
Final result,
Step onto the
60x
stage.
squared 2x
Step
cubed.
onto the
Total
stage.
marks,
Step
2
1,
halves.
build the
Marking breakdown. Based on the CAPS marking guidelines for a typical 2-mark optimization setup question, here is the audit of your work for image_9190E7 link to .png. Step, line of working. Assessment. Mark allocation. Line 1. V equals L times W times H. Correct formula stated. Line 2. V equals 60 to 2x times 2x times left frac x 2 right. Correct substitution of the given dimensions into the volume formula. 1 m line 3 and 4. V equals 60 to 2x x squared. Right arrow V equals 60x squared 2x cubed. Flawless algebraic simplification. Multiplying 2x by frac x 2 to get x squared is perfectly executed, leading to the correct final expression.
Okay, let's go to the next question then, Ito. What are we doing in the next question?
So in our next question, we are determining the value of x for which the volume of the dam is a maximum.
Okay, we're looking for the value of x for which the volume is going to be maximum. Eh?
Yes.
Keyword, highlight that keyword, maximum. So guys, once you see these keywords, maximum, minimum, so you should associate them with differentiation. Even if you don't understand what's going on, just remember that once you see the word maximum, minimize, they're associated with the derivative. No?
Yes.
So we're going to differentiate the volume. Again, this is the only thing that we have. No?
Yes.
So we're going to get the derivative of this volume. So we have 7.2.2. No?
Yeah.
We're going to tell them volume is given as, that's where we start again.
Yes.
Our volume is given as 60x, no?
X squared.
60x squared, okay, minus,
It's minus.
yeah,
Minus
2x
x
cubed.
cubed.
Sure. Now we're going to get the derivative of this one. What are we going to say? We're going to say v prime.
Prime.
So we say v prime.
V prime is equal to
Yeah, so we're going to tell them v prime of x. We're differentiating in terms of x. So it's v prime of x.
okay, it's v prime of x.
Okay, so if you do that, you're going to have 2 multiplied by 6.
2 multiplied by 60 is
120.
120. And then x minus x is 2 minus 1, then we're gonna have x.
Okay, sure.
Then we have 3 multiplied by 2. 3 multiplied by 2 is 6.
6, huh?
We're gonna have 6, and then 3 minus 1.
Squared, you know?
Yeah.
Yeah, the mistake that we can also make, guys, is to transpose everything to one side. But remember, this is a quadratic. Once you see a square, can you see that again?
Yes.
Now, after differentiating, why did you differentiate? You wanted to make the volume to be equal to 0.
Yes.
The derivative of the volume to be equal to 0 because you're maximizing the volume. No?
Yeah.
So I'm going to say 0 is equal to, no? And then you have, if you put it in a standard form, let's try to put it in a standard form. We're going to have minus, again,
Yeah, minus 6x.
minus 6x squared. No?
Squared.
Yeah.
Plus 12x.
Plus 12, yeah. Remember, the 6 is negative plus the 120 is positive. No?
Yes.
Sure. Now from here onwards, we can then say what is common between these two things? What seems to be common? Because it's only two things, right?
Yeah.
What seems to be common between these two things?
We have 6 and x.
It's 6.
Like we have 6 can get into 12 by which is 6 times 2. And then we have 2 x's.
So also we can take out 6x squared, or we can take 6x as a common factor.
Yes.
So if we take 6x as a common factor,
6x. In there we are remaining with minus x.
Minus x, huh?
Plus 2.
Plus 2. Close bracket.
Yes.
Okay, using the zero factor law, first bracket, again, it's 6x. Right?
Yes.
Can either be equal to 0 or the second bracket is going to be equal to 0.
Yes.
So I'm going to tell them what 6x is going to be 0 or
minus x plus 2
minus x plus 2 is going to
equal
be
to
0.
0.
If we take the 2 to the other side, the x, again, the x is positive, is
Yes.
negative.
Yes.
You would say x goes to the other side is going to become positive.
Yes.
It says which x is going to be equal to what, 2?
To 2.
To 2. Okay, now from us to maximize, remember what we're trying to do here? We're trying to get
the volume
what
of
was the
the
question?
maximum.
Let's get the question. Read the question.
Says determine the value of x for which the volume of the term is a maximum.
We want to know which one between the two of them is going to make this thing to be a maximum.
Yes.
It can either be 0 or it can either be what? Be 2. And then yeah, I think we can take this solution and then put it in our senior marker.
Okay, let us put our solution in the senior marker. When we are doing that, we're going to play our song, Still Dancing.
Formula with variables in store. Substitute and simplify. Just one left to explore. One left to explore. Yeah, whoa. Make it one variable. Don't leave it in a mess. Then you take the derivative. Make the power rule drop. Set it equal to 0 so the curve begins to stop. Solve for x, find the value, check if it makes sense. Hey, whoa, no negative dimensions. Keep your logic intense. If they ask for maximum, find the stationary height. Find the stationary height. Fuck up the, plug it back in the original. Lock in the right. Pezzulu, we want the maximum. The highest it can go. Fancy, or the minimum. The lowest of the low.
Marking
Then you
breakdown.
take the derivative.
Based on the CAPS
make
marking
the power
guidelines for
rule
an
drop.
optimization problem, typically 3 marks. Here is the audit of your work for image_919 FCA link to .png. Step, line of working. Assessment. Mark allocation. Line 1, v equals 60x squared 2x cubed. Correct starting function carried over. Line 2, v, x, equals 12x 6x squared. Incorrect. Arithmetic error in differentiation, see feedback. 0. Line 3 to 0 equals minus 6x squared plus 12x. Correct method, setting the first derivative equal to 0 for optimization. 1, m. Lines 4 to 7. Solving quadratic and rejecting x equals 0. Solved perfectly according to your derivative and correctly rejected the invalid root, x equals 0. 1, CA. Total marks awarded. 2/3. Corrective feedback and CAPS compliance. You demonstrated a solid understanding of the calculus optimization procedure, but an arithmetic slip cost you an accuracy mark. The error, line 2, you differentiated 60x squared and got 12x. The logical flaw, you correctly applied the power rule to the second term, minus 2x cubed, right arrow minus 6x squared. However, for the first term, it appears you accidentally dropped a 0 when multiplying the coefficient by the exponent. The power rule dictates that frac d dx ax caret n equals anx caret n1. Socratic question for reflection. When applying the power rule to the term 60x squared, what exactly is the mathematical product of the coefficient, 60, and the exponent, 2? How does this change your final factors and the true maximum value of x? Formal terminology and notation. You used v, x, beautifully here. One minor note for absolute safety in the exam room. Explicitly write the statement v, x, equals 0 on its own line before writing 0 equals minus 6x squared plus 12x. This guarantees the method mark for equating the derivative to 0, even if your derivative is wildly incorrect. Coach's summary. What you did well. Your exam technique for handling the roots is fantastic. You didn't just blindly accept both answers from your quadratic equation. You tested them against the physical reality of the problem. A dam cannot have a dimension of O, and explicitly wrote n, a, to reject it. That is precisely what examiners look for. Area for improvement. Double-check your basic arithmetic during high-leverage steps like differentiation. Calculus problems cascade. A tiny slip at the top means you are doing flawless algebra on the wrong equation for the rest of the page. Take an extra 2 seconds to verify your multiplication when using the power rule.
Okay, guys, as you can see, Itu made a mistake there. I don't know what was going on with Itu. So let's do the right thing, Itu. What is the problem with that question? It's 7.2.2. 7.2.2. Okay, we are going to take whatever we got as from the senior marker. As you saw, guys, the learner, even if we made a mistake here, they didn't penalize us and we didn't get 0. In the marking center, just because you make mistakes, they're not just going to give you 0. They're going to mark the logic. Does it make sense, whatever it is that you are doing? Okay, let's go and try to fix it. You can erase what you wrote them.
Okay, let's just use it with the red pen.
Okay.
Correct ourselves with the red pen.
Oh, we're going to correct us with the red pen. Okay. So, correcting that we're supposed to do from the senior marker, we're supposed to say that we have V. Start from V again.
Yes.
Our V is given as 16.
Yes. X squared.
X squared.
Minus 2.
Minus 2. X cubed.
X cubed.
Right? Let me take charge now. Okay. Next, we're going to differentiate here.
Yes.
Okay. When we differentiate, we're going to tell them that V prime is going to be equal to. So we have 2 multiplied by 60, not 6.
Yeah, 2 multiplied by 60 is 120.
Is 120. So we have 120 x.
Yes.
And then we have 3 multiplied by 2.
Yes.
Well, negative 2. 3 multiplied by negative 2, you get
negative 6.
Negative 6 x squared. Okay?
X squared.
Now, we are going to tell them, they said one of the best thing that we can do is to tell them that V prime is going to be equal to 0. In fact, V prime of x, I thought we're differentiating in terms of x.
Yes.
So V prime of x is going to be equal to 0. Before we actually put it on the equation.
Yes.
So we are supposed to say for maximum or minimum, V prime of x is going to be 0. But that's how our statement should start. It's fine again.
Yes.
The next thing that we're going to do is then to say 0 is going to be equal to 120. Not 12, 120.
120x.
Okay. Minus
6x squared.
Minus 6x squared. Still fine, okay?
Yes.
Now, maybe because it seems a little bit confusing, let's transpose everything to the other side. Let's put everything. So if we take this minus 6 to the other side, it's going to become positive. Right?
Yes.
Then you're going to have 6x squared. Positive. Right? 120 is going to follow this person, right? Goes to the other side. Because it's a quadratic, guys, there's no way which we can then say divide by the one.
Yeah.
Then we're going to have minus again.
120x.
Which is going to be 120x. Huh?
Yeah, which is equivalent to x.
120x, which is equivalent to what? 2?
X is 0.
Which is equivalent to 0. Okay? Then we're going to say we have 2 terms. If you're given 2 terms, there are 2 ways in which you can factorize this. Different of 2 squares, or there's a common factor. The one that we usually start with is the common factor. Is there anything that is common between term number 1 and term number 2? It is.
Yes.
There's an x, and then there's also a number that can go in 120 and 1 and 6.
Yeah.
So we're going to say that we have 6x as a common factor.
6x.
As a common factor.
Open bracket.
Yeah.
Then we are remaining with x in the bracket.
In the bracket, you're going to remain with what? With x.
And then normally you can do it in an easy way. You can say 120 divided by 6.
Yeah. So you want to know who's going to remain here. But what you get if you say 120 divided by, should give us 20 now.
120 divided by 6 is 20, yes.
Yeah, you get 20. It's equal to 0. No?
Yes.
First bracket is equal to 0. So we have 6x is equal to 0.
Yeah.
Or
X
x minus 20 is equal to 0.
is equal to 0.
Okay. Next, what do we have?
We have x which is equal to 0.
X is going to be equal to 0.
Or x is equal to positive 20.
It's going to be equal to positive 20. Now, how do we know which x cannot be equal to 0? Actually, you are given a dimension which is 2x. There was a width which was given as 2x.
Yes.
Yeah. So if you substitute this 0 on that one day, you're going to have a dimension which is 0.
Yeah.
You can't have a term which has a width of 0.
Yeah.
So I'm going to tell them which 0 is not applicable.
Yes.
X cannot be 0.
Yeah.
Therefore, x is going to be equal to what? 20. When they ask us why do we say x cannot be equal to 0, you can give them a reason to say dimensions cannot be 0.
Yeah.
Yeah. Now, with that being said, do you think we should take it back to the senior marker? Are you ready to check yourself, Mike? Do you think you've done
Yeah.
You think you've done it better now. Okay, let's play the song and then you can start it from the beginning. While we're doing that, take it to the senior mother and check if there's any improvement, guys. Please say, guys, if there's any improvement, if he did something better now.
Okay, let's play our song.
Welcome to the Daily Dose of Mathematics. Daily Dose. Optimization questions. Don't let them trick your mind. Trick your mind. All big. It's not just volume. Any formula you can find. Any formula you can find. Surface area, perimeter, or profit on the page. On the page. On the page. Read the question carefully. Step onto the stage. Step onto the stage. Step 1, build the formula with variables in store. Substitute and simplify. Just one left to explore. One left to explore. Yeah, bo. Make it one variable. Don't leave it in a mess. Then you take the derivative. Make the power rule drop. Power rule drop. Set
Final
it
result,
equal to
x
0.
equals 20.
So the
Total marks, 3/3. Marking breakdown. Step, line of working. Assessment. Mark allocation. Derivatives and setup. Initial logic and parameters are validated. Standard differentiation processing applied to reach v, x, equals 120x 6x squared. 1a. Root extraction. Standard processing applied to establish v, x, equals 0 and factor the quadratic. 1m. Final transformation. Invalid dimension root, x equals 0, correctly rejected. Optimal value x equals 20 finalized. 1. CA. Total marks awarded. 3/3. Corrective feedback and CAPS compliance. Your correction is mathematically flawless and perfectly aligned with the CAPS marking guidelines for optimization. Formal terminology and notation. You successfully integrated the explicit statement v, x, equals 0 prior to the algebraic substitution. Furthermore, writing out the reason dimension cannot be 0 inches leaves zero ambiguity for the examiner regarding why you rejected the first root. Socratic question for deepening understanding. Now that you have established x equals 20 yields the maximum volume, what final step would you take to calculate that actual maximum volume if the question were extended to 4 or 5 marks? Coach's summary. What you did well: precision and execution. You successfully identified and corrected the previous.
Okay, guys, we're continuing with question 7.2.3.
Yes.
Okay, guys, let's give Itu a round of applause. He managed to fix his mistakes. Yay. Okay. Now we're going to 7.2.3.
7.2.3. So the 7.2.3
Yeah.
says calculate the maximum volume of the term.
Okay, now we already have our answer. You see, as they were asking, if this question was 5 marks,
Yes.
so what this examiner did, they were breaking down the question. They could have asked us what was the maximum volume of the term. So it's exactly that same question. It's just, but instead of giving us the whole 5 marks, they give it to us in pieces. So how would we get that? We already said we have x for the dimensions,
Yeah.
which is equal to 20. No?
X is equal to 20, yes.
And then we got our volume formula that we got A, that we got it as what?
We got it as
It was 60.
V is equal to 60x minus 2x cubed.
It was 60x squared, 60x squared
Yeah.
minus 2x cubed.
Yes.
Just check it up there so that we don't make a mistake again. Okay, it's fine.
Yeah, it's fine.
So we're going to say V prime. So there, what is it that they're asking us here? Again, this one here, it's okay. This one here, it's V of x.
Yeah.
They want the maximum volume. Remember, if you put x here on the V prime of x, it's not going to give you, it's going to give you 0, because there you're calculating the gradient at the turning point.
Yeah.
So we're going to substitute on V directly from the volume now.
Yeah.
So we say V20. What does that mean? It means everywhere we see X, we're going to put what?
We're going to put 20
Okay, so we have V20
is equal to
60,
60,
Open
open
bracket.
bracket, 20
20
all squared
whole square
minus 2,
minus 2,
open bracket,
open bracket,
20
20
cubed.
cubed. Okay, this one here, you don't try to be hero, guys. You just type it in your calculator.
Okay, let us put in our Casio calculator. We have 60, open bracket, 20, close bracket, all squared. Then we'll have minus 2, open bracket, 20, so for that, minus 2, open bracket, 20, close bracket, cubed. By which our answer is 8,000. That means our V20 is equal to 8,000. So now we found our V20, our maximum volume of the dam. That means we're going to put our solution to the senior marker. While we do that, we're going to play our math song, and then we keep on dancing. As Jaive, your feet.
Curve begins to stop. Curve begins to stop. Solve for X, find the value. Check if it makes sense. Hey, whoa, no negative dimensions. Keep your logic intense. Keep your logic intense. If they ask for maximum, find the stationary height. Find the stationary height. Fuck up the, plug it back in the original. Lock in the right. Lock in the right. Pezulu, we want the maximum. The highest it can go. Highest it can go. Fancy, or the minimum. The lowest of the low. Then you take the derivative. Make the power rule drop. Power drop. Set it equal to 0. So the curve begins to stop. Curve begins to stop. Solve for X. Find the value. Check if it makes sense.
Final result, 8,000.
No negative
Total marks,
dimension. Keep your
2
logic
halves.
intent.
Marking breakdown. Based on the CAPS marking guidelines for follow-up substitution, 2 marks. Here is the audit of your work for image_92136F linked to .png. Step, line of working. Assessment. Mark allocation. Substitution setup. Initial logic and parameters are validated. Standard substitution processing applied to evaluate V20 using the original volume function. 1. M. Final transformation. V20, right arrow 8,000. 1. CA. Total marks awarded. 2 halves. Corrective feedback and CAPS compliance. Your calculation is perfectly executed. You accurately substituted the optimal X value derived in 7.2.2 into the original volume formula from 7.2.1. Formal terminology and notation. You brilliantly implemented the V20 functional notation discussed previously. This clearly communicates to the examiner exactly what operation you are performing. Socratic question for deepening understanding. While the specific units, like meters or centimeters, aren't visible in this specific snippet, if the initial dimensions of the dam were given in meters, what must the final unit of your 8,000 answer be, and how do examiners treat missing units in a final answer under CAPS guidelines? Coach's summary. What you did well. Excellent follow-through. You capitalized on your consistent accuracy, CA, marks. Even if your X equals 20 had been wrong in the previous step, setting up this correct substitution with your previous answer would still guarantee you the marks here. Area for improvement. Protect your final mark by establishing a habit of writing units cubed, or the specific unit like m cubed, next to your final answer when dealing with volume, area, or perimeter, as CAPS marking centers can occasionally deduct a mark for a naked numerical answer in applied geometry contexts.
See a bonga for pulling through the lesson. Hope you caught that daily dose of magic. Like the video and leave us your thoughts.